Hello and welcome back to Survey of Biology. We're going to continue Unit 3, and in Section 2 we're going to talk about a little bit more about evolution, and we're going to be looking about how the variations arise. So in the unit Section 1 we talked about how overproduction of a species leads to some competition. Now why are certain individuals more likely to survive than another? And if you look at this slide here, this kind of breaks it down real quick in terms of evolution. There is variation that is inherent in a population right here, and because of that variation, certain individuals are more likely to survive than others. And if you see the middle picture here where it says differential reproduction, there are some brown beetles and some green beetles, and on the backdrop of the tree bark there, the green ones right here are much more likely to be seen and therefore eaten and not survive. And if they don't survive, they can't reproduce. So the brown beetles, and if you can see here, all of these ones are brown. The brown ones are going to make up a larger percentage of the next generation. The genetic makeup, the gene frequency of that population is changing. Now, there still are some green individuals. There are still green alleles in the population, but it's changing. The brown allele is becoming greater, and that's what evolution is. So we're going to look at the first step here in variation and how that arises. And the big thing to remember is variation arises by mutation. New alleles are generated by mutations, and the big thing to remember is these mutations arise by random chance. It's not driven by the wants or needs of the individual or the population. An individual beetle can't say, hey, I want to be red and have red offspring. So mutations arise by random chance, and they're changes in the DNA frequency that gives rise to a different pigment, maybe a lighter brown beetle or a red beetle, as we see here. So it's mutations that arise by random chance that leads to the variation that we see in populations. That's going to be kind of the raw material for evolution, because if there's no variation in a population, then there can be no selection for certain individuals. And it's variation. If you look, this is a pretty vibrant picture of Cuban tree snails here. And variation is always present in a population. Look around the room and see no two people are alike, no two snails are alike in this picture. And it's those variations, certain ones may be more likely to be eaten by certain predators, some ones might be better camouflaged, some are going to survive better and therefore reproduce. So variation is always present in a population. We're going to be talking about heritable traits here, things that can be passed on. So if you're talking about humans, maybe an individual loses a finger. They're not going to pass that on to their kids. That's not a heritable trait. So all the things that we're going to talk about for evolution, they've got to be heritable traits. And the new alleles, as we talked about in the previous slide, always arise by random mutations in the population. And here's kind of what happens because of that variation. So if we look at number 1 here, here is our initial population, of this case cockroaches. And there's two different alleles. There is a green allele that they're using green, and this is kind of the normal. But there's also in this population, there's a red allele. This individual right here, and there's not very many of them, but that red allele is a mutation, and it makes that cockroach resistant to the insecticide that they're applying. So when a selective pressure, natural selection, in this case a pesticide, is applied, most of the individuals with the green allele are going to die. The survivor, because they have that mutation, because they have a different allele, gets to reproduce. And if we look down here in generation number 2, the population is entirely red. Now, there probably would be some green alleles that would survive, but you can see how evolution takes place over time because of the natural variation present in the population at the current time. So here's another one we've probably heard a lot in the news about things like MRSA, methicillin-resistant Streptococcus aureus, and these superbugs, so bacteria that have become resistant to antibiotics. And those arise because of mutations over time. So if we have a non-resistant bacteria over here on the left, so there is, maybe it can be wiped out by penicillin or ampicillin, and the bacteria multiply by the billions. Well, if you've got billions of copies, there's bound to be mistakes. And some of these bacteria, not very many, but some of them will mutate. Right down here we can see here's our mutation. So now we've got some variation in that population. And some of the mutations make the bacterium drug resistant. So if we apply selection in the form of a drug antibiotic, most of them will die, but a few individuals, because of their resistance, because of the variation, are going to survive, and they're the ones that are going to multiply and thrive, and the genetic makeup, the gene frequencies of that population have now changed over time, and the population has evolved to become resistant to that antibiotic. So that's why some doctors and health professionals now think we need to be careful with all the antibiotic soaps and everything that we use. And we only want to use them when we really want to get rid of bacteria, because most bacteria isn't that harmful for us. But every time we use antibacterial soaps or drugs or anything else, there are going to be certain bacteria that survive because of mutations that they have. Here's another one, an example of bacteria H. pylori, where the normal produces an enzyme and the antibiotic will kill it. No problem. But if there's a mutant that doesn't produce a certain enzyme, it survives. It has a variant that allows it to reproduce in the presence of the antibiotic, and we get a resistant strain of H. pylori. Which is in the stomach, and it can cause ulcers. And here's an example that I want to bring up that is not how evolution works. So adaptation does not involve trying. There's nothing the individual or the population can do to try to evolve. It's the natural variations that are present. So this poor beaver that says chainsaw, 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 he's not going to end up with this new adaptation that allows him to cut trees any quicker than a normal beaver, because that would be a huge advantage. So natural selection does not grant organisms what they need. It's random whether that mutation may be helpful or not. Most mutations are not going to be helpful and may cause the individual to die and be removed from the population. But certain ones are helpful and allow that individual to survive better and pass his genes on to the next generation. So in a nutshell, here's kind of natural selection. So here's birds that are picking up the green beetles, and you can see in the original population, the red beetles are relatively uncommon. And over generations, what happens is, because the birds like the green beetles better, that's the selective force, that's the selective pressure. The genes for the red beetles survive and reproduce, and we end up with a generation that is almost entirely or entirely red rather than the green ones that the birds enjoy better. And I'll just leave you with a Larson cartoon that's one of my favorites in terms of evolution. So again, thanks for your time, and we'll talk to you soon.